Hello everyone, my name is Kevin and I'm a second year student at the University of Toronto.
Hi everyone, I'm Halen and I'm a third year Eng Sci specializing in robotics engineering.
Hi everyone, my name is Armand and I'm a third year engineering science student specializing in machine intelligence.
Hi, my name is Lisa and I'm in third year electrical and computer engineering.
This project stems from the frustrating problems that arise from the inability for cities to properly facilitate throwing away waste in public spaces. As you can see from these examples, even when there aren't a lot of people outside in public, we still see overflowing waste bins and improperly sorted items every single day. Not only is it displeasing to see a bunch of trash on the street during a busy day, but when items are being placed in the wrong bin, so many of our current tools being used to process waste often end up compromised, which wastes millions of dollars and exacerbates environmental problems in a world that is already reeling from climate change. The way we decided to tackle this issue was to nip the problem at its bud, which is why our team came up with a way to sort trash automatically right when somebody decides to throw something away. Using computer vision, machine learning, and some clever design, our compact system is able to recognize the material of a piece of trash and correctly categorizes it in the appropriate bin using a sorting system. We used a wide variety of technologies to implement our solution to the problem of unsorted trash. First, the image classification program makes use of a Raspberry Pi as the brains of the operation. It's the machine that runs our image classification model. Essentially, we used TensorFlow's implementation of the VGG16 model, which is a deep convolutional neural network that is able to identify complex dependencies in image data, to analyze photos taken by our camera module, and accurately outputs a classification. This model was trained on images so that it could identify whether a piece of trash was recyclable and what material category it belongs to. Using this image classifier, we are able to determine whether a piece of recyclable dry waste is made of cardboard, glass, metal, paper, or plastic. As such, using the Raspberry Pi and its tiny camera module, we essentially had a compact sensor system that could accurately tell us which bin a piece of trash needed to be sorted into.
I employed an Arduino Mega to control two standard rotation servo motors, as shown by this schematic. Both servos are powered by a 5-volt voltage source and they are programmed by the Arduino, which is later connected to the Raspberry Pi through a USB serial connection. The Raspberry Pi communicates to the Arduino by sending encoded bytes that are later decoded by the Arduino, and these conditional bytes indicate which angle that the servo motors should rotate to.
Side by side is our CAD design and final prototype. There are three main components. The holding platform is composed of laser-cut birchwood with two barriers that function as both an enclosure for the object and support for the camera. The 3D printed arm is controlled by a servo. Originally designed to push objects off the holding platform, it was converted to a latch in our final prototype to improve sorting consistency. Finally, a servo rotates a slider to 3 fixed angles for the garbage, blue bin, and gray bin.
So here you'll be able to see a short demo of our garbage sorter. As seen, we begin by placing an object in the field of vision of the camera. The camera captures an image and uses the pre-trained model to classify the object. We made a number of optimizations throughout the testing process. The first issue was the severity of the downward angle of the platform, which we solved by raising the front of the device. Secondly, the platform originally had too much friction, which would not allow objects to slide down. This was solved by coating the platform with parchment paper. One area of improvement for our device is its mechanical robustness. Further improving the integration of various components would allow for a more seamless design capable of dealing with both larger and heavier items. Secondly, another area for improvement is the speed and accuracy of the classification model. The ability to quickly sort objects instantaneously would prevent issues such as backlog and overflowing.
The SmartSort qualifies for 2 prizes, the first being the theme of Smart City Automation, as our design is intended to automate the waste sorting process located within Toronto waste bins. The second prize that we qualify for is the Best Unconnected Hack, as all of our components are wired together and our computer vision categorization process is fully self-contained.
Individuals and cities lack the time, effort, or knowledge to properly recycle. By retrofitting every garbage can in Toronto, let's turn this into this with SmartSort.